In this episode, we're going to look at another mocking framework for Golang. We're going to look at Counterfeiter from Max Brunsfeld. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this episode, we're going to refactor the driving license generator tests we created a few episodes ago using hard-coded test doubles. We're going to replace our hard-coded test doubles with ones created by the Counterfeiter mocking framework. Let's look at the code. Before we start refactoring our tests, we'll review the behavior of our driving license number generator that we created using our hard-coded mocks. The point of this code was to show all of the different types of test double that you could use. So let's go through our driving license number generator and see what functionality it has. This is the core of the functionality, the generate function. It takes an applicant, which is an interface defined at the top of the class, with is over 17, holds license, get initials, and get date of birth. The generate function first checks if the applicant already holds a license, and if they do, it returns an error. Then it checks if they're not over 17. And if they aren't over 17, it returns an underage applicant error and logs that happened. If these two guard statements are passed, then it moves on to start generating the driving license number for the applicant. First thing it does is it uses the initials and the date of birth of the applicant to start for the first characters of the driving license number. Then it assigns random digits to the end of the driving license number to ensure everyone has a unique driving license number. So we're using a few different interfaces here. We've already looked at the applicant interface, which is the main one that's passed in. We also have the logger interface, which we use to demonstrate SPY test doubles, and the random number generator interface, which we use to demonstrate mocks or fakes. So let's make a start on refactoring our tests to remove our hard-coded test doubles. Looking at our first test, the test is mainly focusing around the underage applicant. So we will just replace this one test double with a mock generated by Counterfeiter first off. And then we'll move on to the next test. We'll replace the spy logger and the fake rand when we get to the tests that really interact with those parts of our code. So we need Counterfeiter to generate us a mock for the applicant interface. So we'll go down to our terminal. Here's the command we'll be using. We'll be running Counterfeiter. We want the output to go into a folder called mock. We are going to look in this working directory for the interface applicant, and that's what Counterfeiter will generate for us. So let's run this. Let's go and have a look at the mock that's been generated for us. We now have a mock folder and we have a fake applicant. And there's the generated code. We won't look through it, we're just going to use it in a second. It's got all of the functions and it's got a load of variables around each function that we'll access and use during our testing. So let's make a start on removing our first hard-coded test double here. Here we go. Mock dot fake applicant. That needs to be a pointer, like so. And let's go and look at our implementation. So the underage applicant needs to not hold a license and be under 17. We need to configure our mock to return holds license false and is over 17 false. Let's do that. We've got A for applicant dot holds license returns. So we want holds license to return false. And we want A dot is over 17 return false. Yeah. Save. That's the change. So let's run the test and see if our test still passed. And the test continues to pass, so our mock works fine. So now let's move on to our second test. We want to replace this applicant, our hold license applicant, with a mock. So we can use the same mock here. We can actually copy and paste those two lines, and we can say it does return, the applicant does hold a license. Let's run our test and see where we're at. So we've now changed our tests that cover this functionality to use a mock generated by Counterfeiter rather than our hard-coded mocks. So I think we're in a position to remove some of the hard-coded mocks at the bottom of our file. So our underage applicant is no longer used, so this can be deleted. And our license holder applicant also isn't used anymore, so we can remove that. There we are. So let's go and see in our next test what the applicant does. Okay. So now we have a valid applicant. So that's one that doesn't hold a license, is over 17, and then it starts using the initials and the date of birth. So if we take our previous one, modify it. Here we go. So our fake applicant needs to not hold a license, but be over 17. So when we call get date of birth, we need it to return this bit, and get initials needs to return our initials. This can go away. Now if we run the tests, they're still passing, that's great. If we look at our next test, okay, so it's almost exactly the same mock, so we'll do a quick copy paste again, and we're just removing that D from the initials, and see if our test pass. Our test's still passing, so that mock's working fine. Okay, so that's the end of our test. So now we can also remove this valid applicant test double. Here we are. Okay. So we're now at a point where we can start replacing another test double. So if we look at our first test, we make use of the applicant interface to trigger an error to be returned. So we're checking the error here that's returned, but we also check that the logger is called. So we've got a spy logger. So spy allows us to check what happens to our code, test double after the code has been run. So we need to replace our hard-coded spy test double for the logger with another mock generated by Counterfeiter. What we can do at this point is we can run the command again on the command line to generate a different fake. But is there anything we can do to make generating our test doubles easier for people using our code, so they don't have to remember, or we don't have to keep a list of all of the different commands to generate all of the different test doubles? So what we're going to do at this point is we're going to start using the GoGenerate functionality to put the commands into our code. So we don't really have to remember how we run each of the separate Counterfeiter instructions. Those will be set in our code, and then all we have to do is run GoGenerate over our code, and it will generate all of our test doubles for us. So if we put the setup for creating the applicant in first, we can copy that from the command line. So it was this one. Okay, and what we'll do is we'll stick it here. We do go and then generate and give the command. So when we call GoGenerate, it will inspect our code base looking for these GoGenerate tags and then run this command after it. This one will run the applicant one, and then if we take it here, we can create the logger. So if we now run GoGenerate, in the same way we run GoTest, so we go generate, and then so, and then dot, and then slash, and then 3 dots. So that will run over all of our code recursively. And have a look. So we now have a applicant fake and a logger fake that we can use. So let's go about replacing our spy logger with our Counterfeiter logger. L is a pointer to mock.fake logger, like so. That meets the interface, and now we want to inspect what happens after the code under test has been run. So we haven't got call count anymore, so we've got L dot. So we've got log stuff call count. So we expect it to be called once, and then we want to get the message out. So if we look now, we've got L dot, I saw it, here we go. We get arguments for call, and we want 0 call, the first one. So actually we can just stick that here instead of the last message. So, okay. Let's run our test and see if that passes. Great, so that passes. That was a nice easy change. So let's go down, remove this line. Okay, so we've got our spy logger again. So we're going to replace that with the mock. Instead of call count, we will do logs stuff call count, and so last message it's too much there. We can just take this again. So it's a new instance, so it's still the 0 instance we want. Okay, let's run that. Okay, so that test passes. So that's all changed and working nicely with our Counterfeiter mock for the logger. Okay, So we don't use the spy logger anymore, so we can just replace this one, so it meets the interface, so it's absolutely fine. We save that, run our tests. Okay, so we've now made our spy logger implementation completely redundant, so we can remove that as well. So here we go. So this code now disappears as well. Now test file is getting much smaller, so we don't have to have all of these hard-coded test doubles sitting in it. So let's look at replacing our final test double, and that one is the random number generator here. So we will tell Counterfeiter to run against this one. Okay, generate it. Okay. Check it's there, and it is. Okay, so we can quickly fix our first few tests because the fake generator is not used. So we can just, as long as we're meeting the interface, which the mock should do, we can, with these tests will pass straight away. So R is pointed to mock dot random number generator. So let's just check that passes. Okay, so it meets the interface and is working fine. So we'll bring this down to our next test. Get rid of this fake here. Okay, so that fake also passes and works fine here. So now let's go on to the point where we actually replace one that's using it. So this here is using the random number generator to randomly generate these with it 1, 2, 3, 4, 5 zeros. So if we do the replacement, so like so, we can then do the R dot. We can just tell it to return 1, 2, 3, 1, 2, 3, 4, 5. Okay. And let's run our test, see if that works. It does. So we can now take this down to our final test, and this time it's 6 zeros, not 5. Run test again, and they're all passing. So we're now at a point where we can remove our final hard-coded test double. It's all gone, and our code is now really nice and neat. We've managed to remove quite a lot of code from the bottom of our test file, removing all those hard-coded test doubles. But there's still some more refactoring we can do to make our tests even cleaner and slightly more readable. And what we're going to do now is we're going to create a before or a setup step that will instantiate all of our test doubles before each test runs. So we don't have to, we did a lot of copying and pasting, bringing these lines in to every test to instantiate something. We don't need to do that. We can do that in our before each, so that it happens before each test, so that we've got a nice fresh instance of each of our mocks, and we don't have to have as many lines of code in our tests that are just duplicated. So let's make a start on that. Set up. Okay. Okay. So what we'll also do while we're here is we're going to bring the sweet stuff to the top, so it's easier to reference. Okay. So the first mock we want to bring into our suite setup is the applicant. So we can do this. A is a pointer to a mock fake applicant. And then s.a equals, we can bring this in like so. Okay. And instead of instantiating the applicant here, we get rid of this line, and then we just set the one on the applicant on the struct up as we want, and we pass that in here. Okay. Let's check that change worked. It does. So we'll now go and do the one in the next test. So we remove this line, and then it's s.a and s.a. Check again. It's working. So last few. So this line goes. A few more lines. There we are. Pass in the one assigned to the suite struct. Still passing. So we're on to the last one. Okay. So there's the first bit of duplication from each of our tests removed. We can now carry on and do the same for the logger test double. So go to the top, take this, L is pointer to mock logger. So we can get rid of this line. Don't do anything else with our logger. So it's now just s.l. Passed it in. Then afterwards we want to test on the one assigned to the struct. Same with this. This line can go s.l. I didn't test those works. Let's just make sure that does work. And it does. Cool. Okay. So last few tests. So this line goes. Run that test again. And they're passing. So we're now at moving our final test double to be instantiated in the suite setup. So copy this. Do another line there. Number generator. So just delete this line. R and remove. Oh, missed one. This line. Okay, and random number generator is going to go. Last one. Oh no. Okay, let's check that worked. And it did. So that's all of our construction of each of our mocks now moved up to the setup test. But there's one more line that's duplicated through all of our tests, which don't particularly relate to the code under test, and that's to do with the instantiation of our driving license number generator. We could also move this up into our setup. So let's do that as well. Is a where is it? Number generator. There we are. Like so. And then we can take this. This is now s.lg. This is s. So okay, let's run that. Make sure our final refactor worked. And it did. So now if we quickly scan over our test file. So during this video, we have replaced all of our hard-coded test doubles. We've generated test doubles using the Counterfeiter mock generator. And we've also moved the instantiation of our mocks and our test doubles out into a setup function. And we've also moved the instantiation of our struct that will be tested into the setup function, because it's not the code we're directly testing, so we can move it out of our tests to keep our tests clean and ensure that it's very visible in our tests that the thing under test is just the generate function and not the instantiation. So if we quickly scan through our tests, we can see that the tests look quite nice. We can see what's being set up, what's changing for each test, what the scenario is, without having to see everything else. It's quite clear. But this is where actually maybe a final refactor we want to make is some better naming. So what we can do is rename A to the applicant, like so. Do that refactor. Because we've now moved the variable that it's assigned to quite far away from where we're using it. It's much clearer now that the applicant, so we can use that we want to use the applicant. So rather than A, we can use applicant, just to make it a bit clearer, because it's further away, it's a bit of a scroll, just makes it a bit easier when we're looking at the test to see what's going on. Okay, so we can actually do that throughout. So we can change L to logger, and we can change there we go, random numbers generator. There we are. Okay, so now we'll quickly scan over. We've got the applicant that holds a license is false, is over 17 is false. And what should happen there is we should get an error saying underage, and there should also be a log saying that an underage applicant tried to make a request. And then with the duplicate, so that they hold a license already, pass in that applicant, we get an error saying it's a duplicate, and we get a log line saying it's a duplicate. And then finally, in our last two tests, we're checking the actual generation and that we're using the initials correctly, we're using the date of birth correctly, and we are using the random number generation correctly, like so, in those two tests. And it's really clear what's going on, what's expected of the code, what's the expected behavior. I hope you found this quick tour of the Counterfeiter tool useful. I suggest going and play with it. There's a lot of different mocking frameworks out there for Go. This is just one of them. It's worth playing with a couple to see which one you prefer to use or your team prefer to use. I hope this was really helpful, and I'll catch you again soon. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Bradle.